Hey everybody, so today's video is going to be a little bit of a review of slope and then looking at an easier way of finding slope on a graph. Because right now our only way of finding it on a graph is by writing down what the coordinates are and then using our slope formula. So we're going to talk about a little bit of an easier way of doing that. So make sure you got a piece of paper, a pencil out, and a calculator ready to go. Because a lot of this I'm going to ask you to do as we're going along. And then I'm going to be checking your notes in school tomorrow. So make sure that you have notes for this. So as a review, our first review question says, find the slope between the 2 points. We've got 3, -8, and -3, 12. So the first thing that we got to write down is our slope formula. Our slope formula, remember, is y2 minus y1 over x2 minus x1. So in our set here, remember we got the squiggly brackets to define our set. We've got our first point is this one here. Our second point is this one here. Our first x value is 3, so that's x1. -8 is our y1. Because it's our first y value. Second x value is -3. Second y value is 12. And we use subscripts, little numbers underneath the letters, because we want to make sure that we're saying that this is the first y value, not x times 1. So that's why we use the little numbers below the variables. So now if I plug in my numbers, my y2 value is 12. 12 minus my y1 is -8. You're going to have to be very, very careful with your positives and negatives when you're looking at slope. On the bottom, second x value is -3. First x value is 3, so -3 minus 3. Both the top and the bottom have minuses on them. Make sure you're careful with the negatives, because when we do 12 minus -8, remember minus a negative turns into plus positive. 12 plus 8, that gives me 20. -3 minus 3 more, now I'm at -6. When we're looking at slope and we get a fraction with a negative, what I want you to get in the habit of is floating that negative up to the top. So now I've got -20 over +6. Last thing I gotta do is just reduce that as a fraction. The top and the bottom are both divisible by 2. -20 divided by 2, that's -10. 6 divided by 2, that gives me 3. So my slope for this one is -10 over 3. All right, still going on the topic of finding the slopes between points, I want to look at 2 unusual cases. So the first one here, I've got 4, 3, and -2, 3. So again, the first thing I'm going to do is write out my formula. M equals y2 minus y1 over x2 minus x1. Then I'm going to go ahead and label my points. I know that this is my first point, so I'm going to have x1, y1. Second point means x2, y2. So then when I plug these points in, my y2 is 3, my y1 is 3. 3 minus 3 on the top. Then I've got x2 is -2, x1 is 4. When I subtract these, 3 minus 3 gives me 0. -2 minus 4, that's -6. 0 divided by 6. I've been seeing a lot of people do these wrong. 0 divided by any number is going to give you 0. 0 divided by any number is 0. So this one would have a slope of 0. Now let's look over at this case over here. Again, I'm going to label my points x1, y1, x2, y2, and then I'm going to plug them in. y2 is -2 minus my y1 is -11 over x2 is 7 minus my x1 is also 7. On the top, -2 minus a negative turns into plus positive. -2 plus 11, that gives me 9. On the bottom, 7 minus 7, that gives me 0. So on the bottom, I'm left with 0. Any number divided by 0. If you aren't sure which is which, just type it in your calculator and see what you get. If you type in 9 divided by 0 in your calculator, it'll come up with an error message. That's because we can never divide by 0. So in this one here, this one would be undefined. So if you get something like this where you have to divide by 0, that means that the slope is undefined. Over here, if you get 0 divided by a number, that means the slope is 0. That doesn't mean there's no slope. That means that the slope is just 0. If you think about that on a ski hill, if you had a slope of 0, that would just be flat ground. There's no rise, there's no run, it's just a flat ground. It's just a slope of 0. All right, for this next one, I've zoomed you way in because I've got a kind of a smaller graph here that I want to show you, and it says to find the slope of the line. So we're going to do this in 2 ways. I'm going to show you kind of the way I think is a little bit more difficult, but works if you have a test that's on the computer. And then we're going to use a way that's going to work if you have the test on paper, and it's a little bit easier if it's done that way. So this first way I'm going to do it, I'm going to write down my steps on this side. The first thing I'm going to do is I'm going to locate 2 points. So I'm going to choose any 2 points that are on this graph. I'm going to choose ones that are kind of easy and straightforward. I'm going to choose this one right here and write down those coordinates. I'm going to do that in purple. Remember, we do x, y, so the coordinates for that point is 0, 2. And then I need one more point. I'm going to go ahead and choose this one right here just because the coordinates of that point, 2 to the right and 1 down, so 2, -1. Then I bet you can guess what step number 2 is going to be. Plug the points in to the slope formula. So remember my slope formula? M equals y2 minus y1 over x2 minus x1. Plug in my points. Let's go back here and label them. Remember, this is my first x, my first y, my second x, my second y. Make my y's look a little bit better. So when I plug them in, my y2 is -1, my y1 is 2, my x2 is 2, my x1 is 0. That makes things easy. Anytime you can include 0 in this slope formula, it makes things easier. -1 minus 2 is -3. 2 minus 0, that's easy, that's just 2. Then this one wasn't so bad, but step number 3, just in case, if you have to do it, would be to reduce. So reduce if possible. But since it's already 3 over 2, we're going to -3 over 2, we're going to leave it as -3 over 2. So this one had a negative exponent, so it was pointed down. If you have a negative exponent, or not a negative exponent, a negative slope, if you have a negative slope as you move from left to right, your graph is going to go down. So any graph that looks like this, where it points down as you move to the right, is going to have a negative slope. All right, we're going to do another one using that same method where we pick out 2 points, plug them into the formula, and solve it. First thing that we should notice about this one, is it going to be a positive slope? Is it a negative slope? Judging based on the graph, it points up as we move to the right, which means it's going to be a positive slope. So if it moves up as we go left to right, it's going to be a positive slope. So let's go through our procedure here. Step 1 was to locate 2 points. I get to choose any 2 points. Let's go ahead and choose, I always like to choose the one that's on the y-axis. So this one is down 3, so it's 0, -3. Then let's go ahead and choose this one all the way over here, because that's also on an axis. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 0. That's going to make things easy for us in step number 2. I'm going to go ahead and label my coordinates as x1, y1, x2, y2. I said I was going to make my y's better, and I still didn't. All right, I'm going to plug it in here. y2 minus y1 over x2 minus x1. All right, minus a negative turns into plus positive, so 0 plus 3, that's just 3. 12 minus 0, that's just 12. Then we got to do step 3, which is to reduce if possible. 3 over 12, well, we can divide the top and the bottom by 3 to get 1 over 4. So my slope in this one is 1 over 4. All right, so we talked about how there's 2 ways to do this if it's on a graph, and we went through a couple examples of that first way, and that was just writing down the coordinates of the points and then plugging it into our slope formula. This next way is going to look at how to do it if you have the graph rather than plugging into the slope formula and worrying about adding and subtracting. A little bit easier of a way. So we've talked about slope quite a bit, and we said that slope is that y2 minus y1 over x2 minus x1, but we also talked about it as the change in y over the change in x. If we look at it on a graph and we look at the change in y, our y values go up and down. So if we look at our change in y, another way of talking about it just on the graph is looking at our rise on our graph. Looking at how much it rises from point to point. Then our change in x is going left and right. Another way of saying that is our run. So we've got our rise over our run, and I'm going to be saying that a ton in the next few weeks here. Our slope is our rise over our run. How much do our y values change by divided by how much do our x values change by? So now what I'm going to do is I'm going to look at what that looks like on the graph here. So again, I'm going to pick any 2 points. I'm going to choose this one down at the bottom here, and then I'm going to choose this one right here. We got to choose points where it crosses the grid markers nicely. So now I got to figure out what my rise is and what my run is. To figure out my rise, I'm going to start at that left point, and I'm going to go up until I'm even with my next point. So I have to go up 1, 2, 3, 4 times. So my rise is 4. Then I'm going to start right where I left off, and I'm going to run until I'm even with my next point. I'm going to go 1, 2 to the right. So my run is 2. So my rise over run is 4 over 2. 4 divided by 2, that simplifies to 2. So my slope in this one is 2. Now, it doesn't matter which points that you choose. You're going to get that same thing every single time. It's going to be proportional. We're going back to that word proportional. Because if I choose 2 other points, let's say I choose the first point here and the last point here, go through that same process. Go up until you're level with it. Count how many times you went up. 1, 2, 3, 4, 5, 6, 7, 8. I went up 8, so my rise is 8. That's a terrible looking 8. I apologize. My rise is 8. My run then, I go start where I left off and run until I'm even with it. I run 1, 2, 3, 4 times. 8 divided by 4, that is still 2. So it doesn't matter which points that you choose as long as you do rise and run. Now, we're going to go through the step-by-step procedure for this, just like we did before. So make sure you're ready to write down your step-by-step procedure. All right, here comes our step-by-step procedure. Step number 1 is going to be to locate 2 points. So on this one, it's easy. On my graph, it only gives me 2 points. I've got this point here, and I've got that point there. Step number 2, we're going to start at the left point, always the left point first. We're going to start at the left point and find the rise. So I'm going to start at this left point. Now, one thing you should notice is this one is it moves down as you go to the right. That means it's going to have a negative slope. If it moves down as you go to the right, it's going to be a negative slope, which means my rise is going to be a negative number. So if I start at this left point, to get level with the right point, I actually have to go down, and I have to go down 1, 2, 3, 4. So in this one, my rise is negative 4. And then step number 3, I guess I'll do that in purple. I'll do it in black. Step number 3 is going to be run until you match a point. So I'm going to start where I left off, and I'm going to run until I'm matched up with the point. So I ran 1, 2, 3, 4, 5, 6, 7. So my run is 7. I'm sure you can guess what step number 4 is going to be. Let me move you down a little bit. Step number 4 is find rise over run. So my rise is negative 4. My run is 7. That's as fully simplified as we can get it. Negative 4 over 7. All right, last thing that I want to talk about is I want to make sure that we're clear that there are 4 types of slope that can happen. Either the line is going to look like this and it moves up from left to right, like this as it goes down from left to the right, it's straight across, or it's straight up and down. Those are the only 4 types of lines that you can have. Now, they might be shifted around, they might be a little bit more slanted than others, but these are the 4 general types that you can have. So if we look at the slopes that can happen for these types of lines, I didn't put any specific numbers in, but if we look at rise over run for these, If I look at my left one, if I'm going up, that means I'm going to have a positive rise. If I'm moving to the right, I'm going to have a positive run. So this is a positive over a positive, which makes the whole thing positive. So if it moves up from left to right, it's positive. Second one, from here, I have to go down to get level with it. So that's going to be a negative rise. But then I move to the right, so that's a positive run. Negative rise divided by a positive run, that makes the whole thing negative. Over here, if I'm moving straight across, that means my rise is 0. I never go up or down. So my rise is 0. My run is going to be positive. 0 divided by anything is going to be 0. So any horizontal line is going to have a slope of 0. Last one, vertical, straight up and down. My rise is going to be positive because I'm going up, or I'm going down, doesn't really matter. But then I don't run. I never move left and right. So I divide by 0, and we can't do that. So that becomes undefined. So those are the 4 types of slope that you can have. Based on looking at them on the graph, you should be able to determine, is it positive? Is it negative? Is it 0? Or is it undefined? And in doing so, that's a good way of checking to see, did you do it right? Did you do the subtraction right? Because if you're doing one like this, and you do the subtraction, you get a positive number at the end, go back and see, did you do something wrong along the way? All right, make sure that you've been taking good notes. Tomorrow in class, I'm going to be checking off to see if you've actually taken good notes. Otherwise, have a great rest of your day. I will see you tomorrow.